Welcome to The Explainer. Today, we are tackling what is, for many, the most dreaded part of any system design interview, those back-of-the-envelope calculations. But what if I told you there's a framework that can turn this moment of fear into your chance to absolutely shine? Well, stick around, because that's exactly what we're going to do. So, just imagine it. You're in the hot seat, the pressure is on, and the interviewer hits you with this monster of a question. Your heart starts pounding, right? And your brain immediately jumps to, okay, servers, storage, how many do I need?
But wait a second. That first instinct, the one that tells you to grab a metaphorical calculator and start crunching numbers, that is the #1 trap. It's the biggest mistake most candidates make. And honestly, it can derail your entire interview before you've even really begun.
So that brings us to our first big idea, the estimation trap. We got to understand the real goal here. Because if it's not a math test, then what is the interviewer actually looking for?
And here's the absolute key. This whole exercise, it isn't a math quiz. They don't really care if your final number is perfect. What they want to see is how you think, how you reason, when you don't have all the facts. Just like a real project, where the requirements are always a little fuzzy and you can never predict exactly what's going to happen.
This slide perfectly sums up the difference in mindset. A junior engineer, they get obsessed with getting the right number. They think that's the whole point. But a senior engineer, they focus on something completely different, creating a reasonable plan that's built on a foundation of clear assumptions. And let me tell you, that's the person they want to hire, every single time.
All right, let's get practical. Time for our core calculation framework. We're going to build this thing from the ground up, and you might be surprised where we actually start. It's not with servers or databases, it's with people. Okay, first things first, we need a foundation, a clear, defensible assumption about our users. So, for a social media app like this, let's just say we're designing for 500 million daily active users. By stating this right up front, you're showing the interviewer, hey, I'm grounding my entire design in reality, in how people actually use this thing.
Okay, we've got our users. Now, what are they actually doing? Let's make another simple assumption. Let's say each user performs about 20 actions a day. Stuff like scrolling the feed, liking a photo, maybe making a post. Well, you do the math. 500 million users times 20 actions, that gets us to a whopping 10 billion total requests per day. See? Simple, clear, and totally logical.
From there, we can figure out our per second rate. You just take that 10 million requests, divide it by the number of seconds in a day, which is 86,400 by the way, and you land at around 115,000 requests per second. But here's the thing, this number is a trap. It's dangerously misleading, and pointing that out is your next big move.
And this is the part where you literally say this sentence out loud to your interviewer. This is the average traffic. Real systems are built for peaks. Seriously, just saying that one sentence immediately flags you as a senior-level engineer. It shows you know that in the real world, traffic is never, ever flat.
And this chart shows you exactly why that's so critical. Just look at the difference. On the left, you have our nice, comfortable average of 115,000 RPS. But on the right, that's the peak. A really common rule of thumb is that your peak traffic can be 5, even 10 times your average. So suddenly, we're not designing for 115,000 requests per second anymore. We're designing for something closer to 600,000. It's a completely different ballgame.
So now that we have our real number, that peak traffic number, we can finally start talking about servers. Let's just walk through these steps together. First, we've got our peak RPS, 600,000. Got it. Second, we use a handy rule of thumb. One CPU core can handle about 1,000 requests per second. So that means we need about 600 CPU cores total. Third, we figure out how many servers that is. If we're using machines with, say, 64 cores each, that's roughly 10 servers. But, and this is super important, we are not done yet. You always add headroom. So step 4, we add a 50% buffer for safety, for unexpected spikes, which brings our final, more realistic estimate to about 15 servers.
All right, you've got the basics down. Now it's time to add that pro-level polish. Let's talk about what I call the senior multipliers. These are the concepts that will take your estimates from good to absolutely fantastic and really blow your interviewer away.
Okay, when you get to storage, you have to say this. Text is almost irrelevant. Media defines our storage and bandwidth needs. Think about it. Even if only a tiny fraction, like 5%, of your content is photos and videos, that tiny fraction will absolutely dominate your costs. It's not even close. Pointing this out shows you know where the real money gets spent. It's a huge green flag for any interviewer.
The next game changer is caching. And like it says here, caching isn't just some small tweak or optimization. Introducing a cache can literally change your resource estimates by an entire order of magnitude. It's that powerful.
And just look at the impact right here on this chart. Let's say you achieve an 80% cache hit ratio, which is pretty standard. That big slice means that 4 out of every 5 requests never even touch your backend servers. They're handled by the cache. Only that little 20% slice actually makes it through. Your backend server load just plummeted by a factor of 5. That's a massive win for cost, for speed, for everything.
You know, a junior candidate gives you the raw number and stops. A senior candidate knows that's just the starting point. You have to account for all these hidden multipliers. Your data isn't just stored once, it's replicated, usually 3 times for safety. You need backups, you need indexes for your database, which can sometimes double your storage needs right there. Forgetting this stuff? That's a classic rookie mistake. And last but not least, you always have to be thinking about the future. Saying something simple like, I'd size for today's load, but I'd probably multiply that by 2 or 3 so we don't have to re-architect this whole thing in a year, that is pure gold. It shows you're not just solving a puzzle, you're demonstrating real ownership and the kind of strategic thinking they need to build systems that last.
Okay, this brings us to the grand finale, telling your design story. Because at the end of the day, it's not about just dumping a bunch of numbers on the table. You have to perform. You have to weave it all into a story and confidently narrate your thought process. So here it is. This is your ultimate takeaway, your simple mental checklist for the interview. As you're talking, just mentally tick these boxes. Start with users, move to requests, average and peak, then CPU, storage, caching, and finally growth. I'm telling you, if you can hit most of these points, you are already way, way ahead of the curve. When you do this, you completely transform the dynamic. It stops being a stressful question and answer session, and it becomes a compelling presentation of your engineering judgment. You're not just answering their questions, you're leading the conversation. You're telling the story of the awesome system that you would build. Look, by using this framework, you're not just giving an answer anymore. You're proving that you have the structured thinking, the real-world production-aware mindset that it takes to build robust, scalable systems. So the only question left is, what story is your next design going to tell?